Inverse variation. Well, inverse variation works exactly the same as direct variation, but because it's an inverse, we write it as 1 divided by. That's what we meant by inverse, and they usually use the words inversely proportional. So when we see this, t is inversely proportional to b, we'll write t is inversely proportional to b. Okay, so in general, y is said to vary inversely as x. We write, well, that is y equals, but when they say varies directly, y varies inversely as x like that, we will write y varies inversely as x, and then we get our equation y equals kx. Example 4. In each case, determine the constant of variation k and hence complete the table. So we've got our rule there. We need to turn it into equation. So we've got y equals k over x squared. We need to find our k sub. Doesn't matter which one you substitute in. X is 2 and y is 0.1 as we want to substitute in. So I get 0.1 equals k times 2 squared. 2 squared is 4. So when I work this one out, my k will equal 0.4. And therefore, my rule is y equals 0.4 divided by x squared. When I work out for all of them, I end up getting, and I'll just write the answers here, 0.004, and for this one it was 20. Now I haven't shown you the steps there, but I'm sure you know how to substitute it and work it out. So that was part A. Part B, this time we have y equals k divided by the square root of x, and the square root of x is just x to a half. I'm just going to leave it as the square root of x. I'm going to substitute x is 1 and y is 10 in there, so I get 10 equals k, square root of 1 is 1, so k equals 10, and therefore my rule becomes y equals 10 divided by the square root of x. And then when I substitute this part in, x equals 4, I get y equals 5, and if I put y equals to 2, I end up getting x is 25, and I'm sure you guys know how to do that as well. Example 5. For a cylinder of fixed volume, the height, h centimeters, is inversely proportional to the square of the radius r. So when I'm to write this rule, I get h inversely proportional to the square of radius, r squared. And therefore I get h equals k divided by r squared. Then part A says, what percentage change in the height would result if its radius were reduced by 25%? So that means I need to start with something. So I'll start with, if r equals 1, then h equals k divided by 1 squared, which means it's k. Now, if it's reduced by, what was it, 25%, then we have r equals to 0.75, because r is 1, so it becomes, it's 100.75. Then h, k, divided by 0.75 squared. And therefore I end up getting h is approximately 1.778 k, and that's 3 decimal places. And then we can work out the percentage that it's reduced. So percentage reduced will be 0.778 k divided by the original, which is k, times it by 100, just like we did before, so 77.8%. So that's part A. Part B, if a cylinder of height 15 centimeters has a base radius of 4.5 2 centimeters, how high would a cylinder of equivalent volume be if its radius were 3.5 centimeters? So when we substitute into our rule, we get 15 equals k divided by 4.2 squared. So therefore k ends up being 264.6. And therefore h equals 264.6 divided by r squared. But if r equals 3.5 centimeters, they give us that, then h is going to be 264.6 divided by 3.5, that's r all squared, which means it's 21.6 centimeters. That's what the height will be.